So acceleration is definitely not the same as velocity or speed. It's totally different. Acceleration is the rate of change of velocity. Okay, so it's the rate of change of velocity. We can instead say that it's how quickly something is speeding up. Okay. Acceleration is also a vector quantity. Okay, so it's got a direction associated with it. Now, if you've got negative acceleration, that doesn't mean that it's going backwards. That doesn't necessarily mean it's moving backwards. If you've got negative acceleration, that just means you're slowing down. Okay, so it's a vector quantity. So the direction indicates whether you're speeding up or slowing down. If it's not got a negative sign next to it, then it's speeding up. And if it has got a negative sign next to it, then it's slowing down. Okay, so it's a vector quantity. Now, whenever we describe something as a rate of change of something, the formula will always look the same. So if it's a rate of change of velocity, then it's always going to be something divided by time. That's just what we get when we get rate of change equations. So in this case, it's the rate of change of velocity. Yeah. So we're going to get velocity divided by time, and that's what acceleration is. Okay, that's in meters per second. And we're going to divide time taken in seconds, of course. And that's what acceleration is. Okay. So if you've taken something in meters per second, if you're taking change in velocity in meters per second and you're dividing it by time in seconds, that's going to give us a unit of meters per second, which is, you can just write that it is meters per second squared. Okay, so meters per second squared. That's what we get when you take meters per second and you divide it by seconds. You might see this written down more frequently as the change in velocity. Remember, this delta symbol here, this triangle, means change in. So this is the change in velocity divided by the time taken is equal to acceleration. Okay, so that's the same equation, just with symbols instead. Right, let's have a look at a practice question just to start. So if a car is accelerating from 10 meters per second to 25 meters per second, and it does it in 5 seconds, calculate its acceleration. So in order to calculate its acceleration, remember, we take the change in velocity and we divide it by time. Yeah, this is an equation you will need to remember. Yeah, if you're doing AQA, you need to remember that change in velocity divided by time is acceleration. So the change in velocity from 10 to 25, what's the change in velocity between 10 to 25? Well, it's changed from 10 to 25, so it's 15. Yeah, and how long has it taken? It's taken 5 seconds. So we've taken 15 and we're dividing it by 5, you get 3. Now remember, you have to give a unit. You can't just leave it as 3, you have to give a unit. So what's the unit for acceleration? Remember, meters per second divided by seconds, meters per second squared. Yeah? So here's a second question then. So this time we've got a car moving at 10 meters per second and it's applying its brakes and comes to a stop. And it does that in 2 seconds. So calculate the acceleration this time. So we can use the equation again. Change in velocity divided by time is equal to acceleration. So what's the change in velocity from 10 to 0? If it's come to a stop, it's gone to 0. So from 10 to 0, it's 10. But is it 10 or is it minus 10? It's minus 10 because it's gone from 10 and it's gone down to 0. So it's minus 10 for change in velocity. Divided by the time of 2 seconds, minus 10 divided by 2 gives you minus 5 meters per second squared. What does it imply if you've got a minus sign in acceleration? Remember, if it's got a negative sign, it's decelerating. A negative acceleration is slowing down. So in this case, it's slowing down, which makes sense because look, it's applied its brakes. Yeah, so it's slowing down in this case. Right, there's a couple more questions down here that I want you to have a go at. If you have a go at those, I'll put the answer in the description. And I'll see you in the next video where we'll look at uniform acceleration. Okay, so there's a slightly more complicated equation for uniform acceleration that we'll look at in the next video. I'll see you then.